Okay, so this lesson, 24.1, we're going to be talking about graphs of polynomial functions. So the first thing I wanted to do is just to remind you of some graphs that you already know about. So you know when the equation y equals x, that's just going to give us a linear equation. And in general, that's just going to be a straight line. Now the line could go up or down, it could be have a different steepness, but in general, we're just talking about straight lines. Exponential, it's been a while since we did these, but that's when you have x as the exponent in the equation. An exponential look like this. Could actually maybe draw that a little bit better. They get big really, really quickly. And if you remember, on this left-hand side here, they are going to approach this line but never actually get to zero. And if that right there is called an asymptote, A-S-Y-M-P-T-O-T-E. All right, and then we also have quadratics, which means it's x squared. And as you all know, that means you're going to have the parabola shape. Now, some things that I want you to note, or just to remember, parabolas, so they can have two real roots. That's like normal. But there are two special cases. One where you have a double root, because we're going to see this a little bit today. So double roots look like, if you remember, that's when the parabola like touches, wow, I should draw that better. That's when the parabola touches the x-axis but doesn't actually cross through it. And then bounces kind of back the other direction. And the other option is to have two imaginary. And our imaginary roots is when it's not crossing the x-axis at all. So keep those in mind. So our general polynomial functions, so polynomial is when you have things that have higher degrees. So we know x and x squared, but what's the graph going to look like when I start having higher degrees, like to the third, to the fourth, to the fifth, to the sixth, and so on. So I just want to show you, you don't necessarily have to copy this in your notes, but you may find it helpful later on. And remember, y equals x in this first one just gives us a linear function. X squared is going to give us a parabola, and that's going to cross 2 times. So a linear function crosses once, parabola crosses twice, so x to the third is going to have to cross 3 times. All right, so that's, and remember, I'm just looking at the x-axis, 1, 2, 3. X to the fourth, then, is going to have to cross 4 times. 1, 2, 3, 4. X to the fifth is going to have to cross 5 times. And I'm going to draw one specifically for us here. All right, this is 1, 2, 3. And now some people say this looks like 4, but remember this one right here, that's a double root, so really that's 1 and 2. 3, 4, and 5. So that's still 5 times. And then 6, man, the squiggles just get like kind of crazy. So 6 is going to cross 6 times. And I want to show you on this one, this is 1, 2, 3, 4, and 5 and 6 are right here. They're imaginary roots. So that's 5 and 6. That's my 2 imaginary. So know that the degree is going to be the number of times it crosses the x-axis. All right, the other thing I want you to take a second to see if you can figure out is notice what do these all have in common, the 3 that I'm circling in yellow. All right, and I'm talking really just about the ends of them. And then think about the other set that you have that I haven't circled. What do they have in common? So the things that I want us to note, we're going to take notes on the other page, but you might need to kind of go back so you can look at this visual one more time as we're taking our notes. Okay, so if the degree is odd, then the end behavior is opposite. So what we had drawn there, if you haven't drawn it already, you may just want to draw an example or two for yourself. X to the third looks like this. And when I say opposite, what I'm talking about is how on one side it goes up forever, on the other side it goes down forever. And the same thing happens if you have like x to the fifth, right? It's going to have lots of different curves in it, but it's still going to be opposite directions. If the degree is even, the end behavior is the same. So when we have like x squared, think about a parabola, those both are going to go up and up, the same direction. right? Or you could have, they could actually both go down. That's an option too. So let's think about when does it cause it to go up and down, and we can fill in the rest of these notes. So this is an example showing you the difference between positive and negative. So both of these, I see that they both have opposite directions, so they're both going to be odd. And then they both cross 3 times, which makes sense, so that means I'm going to have a degree of 3. Think about if you were riding on a roller coaster, if this is a roller coaster, if you look at the end, you're going up forever. And when I say the end, I'm talking about the right side. So it's the right side that we want to look at. And since this is going up, this first one is an example of positive. The second one, if you follow the tracks, you're going to be going down on the right side. So that's an example of negative. All right, so that's the part we have left to fill in our notes. Look at the right side to determine positive or negative. So if it were me, I would write that note and then maybe just give yourself a little sketch of positive goes up and then negative is going to go down on the right. And then roots equal degree, and I put a little star next to that because sometimes if you have double roots, it doesn't look like it crosses that many times. So I just want you to keep that in mind. All right, so we're going to do 2 examples here pretty quick. They want us to do 2 things, and I'm going to add 1 thing to that. So first, odd or even. So I noticed that in question 3, these arrows, the endpoints go in opposite directions. So opposite is going to mean odd. That means the degrees I have to choose from are 1, 3, 5, 7, so on and so forth. And then they want me to say positive or negative. And I look at the right-hand side, and the right-hand side is going down. So that means I'm going to have negative. Now, what I want us to add is to write an equation. So if we're going to write an equation here, I know I'm going to have y equals. I need a negative number in the front, so I'm just going to pick -2. That doesn't matter. Any number works. Anything that's negative works. And then I want to have x to the... so we need to pick one of these odd things. And if you look, this one's a tricky one. This has just 1 root. So for a minute, you might think, oh, well, I should pick a degree of 1. But if you leave it like what you have written right here, anything to the first power is linear. That means this should be a straight line. But this is definitely not a straight line. So I have to pick the next lowest exponent, which is 3. So that is a possible equation. That's how you can label that, as possible equation. Remember, 1 didn't work because that would have been linear. All right, example 4, we'll do the same thing. So example 4, the ends are doing the same thing. So that means that's going to be even. And if I count 1, 2, 3, 4, it's got 4 roots to it. And then on the right side, I'm going up. So that's positive. So here, if I write my equation, a possible equation could be y equals 2x to the 4th. Notice that this time, the 2 that I put in the front was a positive 2 because it's going up.